My name is Mohit Chhabra. I work as a configure. I work at Configure as Cloud Operations Manager, and also I'm the architect at the same company. And I'm also Microsoft Azure MVP. So going to the topic that I'm going to speak about today, securing your SQL data with the power of blockchain. Sounds interesting, right? Maybe that's why you're in this room, right? How many of you know what is blockchain, or how many of you have heard about the word blockchain? Wow. How many of you know what is blockchain? There is a misconception that people think that blockchain is Bitcoin. How many of you think blockchain is Bitcoin? No? And the vice versa is true? Bitcoin is blockchain? Exactly. So Bitcoin is basically built on the concept or the technology called blockchain. But all blockchain is not Bitcoin. So blockchain as a technology was developed by Satoshi Nakamoto, who is the founder of Bitcoin. But then we identified that the whole technology itself is so unique and so powerful that we can use it for different scenarios. And I'm not going to go deep into it right now, but we can go into next slide. So talking about the blockchain, the idea of the blockchain that is that the transitions that we do, it basically happening and storing in a block. And what we are doing is we are hashing that transition, all the data, and putting it into something called block. And when we generate a new block, we have to link it to the another block. So that's how a chain is formed. One block data, hash. So what we do is basically in the blockchain, we create a hash of the data of the transitions, and we store it in a block. Once this block is filled, we create another block and link to it. And this whole process is called proof of work. There are different concepts around blockchain, proof of work, proof of stake, proof of history. I will not go deep into that. If you want to have that discussion, feel free to catch me after my session. We can take it offline. But the whole idea is we secure the data, the transition, with hashing, and we put that hashes in the form of blocks in the blockchain. Does that make sense? Okay. So just because we are putting it in a blockchain, the idea is in the blockchain, all the data is immutable. That means you cannot change that data. You cannot make any tamper to that data. Once data is in the blockchain, it stays there forever. No one can change it. No one can modify it. So that brings a lot of trust in the companies. As a software engineers, we are building application, and as a company, the company needs application which can bring trust in the whole organization, in the whole setup, in the whole processes. So for the auditing purpose, a lot of the companies are moving from the old digital boring way of auditing to more process-oriented way and lower risk, which is all more digital in nature with the power of blockchain. Blockchain is basically growing tremendously. The market that was supposed to happen, this is an old article, and the crypto market itself last year was like $2 trillion. How many of you invest in crypto? Just out of curiosity. Few guys, nice. So the whole blockchain industry, be it crypto, NFT, all the enterprise application that we can build around blockchain is only going to increase from here because of the trust, the power that blockchain brings on the table for us. But there is an issue as well. What is the issue? The issue is that blockchain can be an overkill for most of the applications that we are trying to build on top of it. Because blockchain, in theory, is a very good concept. Blockchain, in practical, is very difficult to implement. When I say that, blockchain has something called distributed ledger. How many of you understand what is a ledger? Raise your hands, please. So basically, a ledger is like an account book where all the transaction is stored. And a distributed ledger basically means that this ledger is not there in one server. It's not at a centralized location, but it's distributed across different locations. And that's why it brings trust, because it's easier to hack one computer, but it's difficult to hack thousands of computers and then change everything. In order to change everything in those, we need to have 50% of this distributed ledger hacked, which is in theory or in practical very difficult to happen. That's why when we say that building application with distributed ledger, something like Bitcoin is an application of distributed ledger, right? All of you can mine a Bitcoin. How many of you have heard about mining a Bitcoin? All the spammers use that, right? No. They also use it, but it's also used by a lot of other people. I mine Bitcoin as well. So it's not profitable anymore, but that's a different theory. We'll talk about it later. The concept that we have is that with the help of distributed ledger, the whole thing of transitions is distributed across multiple locations, multiple computers, multiple servers across the world. And that brings the trust because once it goes to the blockchain, you cannot revert it back. The data is there forever. It's immutable. That's the word. So for most of the enterprise scenarios, do we need that? Probably not. And that's the next thing that we're going to talk about. That is the overkill for a lot of centralized scenarios. Because what happened, that in a distributed ledger scenario, all the different nodes have to validate that transition in order for transition to succeed. What happens is in a distributed setup, if you're mining, you basically, what you're doing is you're approving a transition. And in order to approve a transition, you need to have some sort of policies in order to make sure that the transition is succeeded. So in most of the cases, we can say that, okay, at least we need 10 verification from different ledgers to make sure that the transition is succeeded. And this transition is now copied to all the servers. So far, am I clear? Perfect. But this distributed ledger thing, what happened is that it's easy if it's centralized, but if it's a distributed, it also takes a lot of time because it has to be distributed and it has to go through different servers, different nodes that is running these transitions, and then update this data. How many of you have used Ethereum or sent money through Bitcoin, Ethereum, doing the transfer to digital currency? No? No one? So normally, how many of you have used UPI? Paytm, UPI, all of us. How quickly we can send money from me to you or you to me? Within seconds, right? But that's not the same with cryptocurrencies. There are few cryptocurrencies which works on blockchain 2.0 with the proof of stake and all that stuff. But by theory, with the proof of work, it's not the same because of this distributed ledger. It's very difficult to copy all this transition into all the different nodes and get the transformation from the different nodes to make sure that the transition is successful. So getting that confirmation in the first place takes time. And normally, if you do a Bitcoin transfer, it can take up to 10-15 minutes as well. The worst case I have seen in a Bitcoin network, because it was congested, was around 8 hours. And trust me, by the time I was waiting for this 8 hours, that was the longest 8 hours of my life, because there were like 2 Bitcoins that I sent. So I was quite nervous whether I will lose those Bitcoins because I've sent from one place to another place, and 8 hours is a big time. So overall, the issue that we have, that it's very time consuming. The transitions itself is a very time consuming and which is not suitable for most of our enterprise applications. Right now, the kind of application we build, we want to get the response and things done in milliseconds. As a user, if I sit and then build an application and there is a loading screen, I won't go back on that application, right? How many of you love IRCTC website? We all do, right? Because if you go there and then try to book a car ticket, it will just sit down, keep on loading, and it never loads, and it will say timeout. And you're like, wow. So as a user, we don't have patience anymore, right? With all the social media reels, right? I'm just mindlessly scrolling these reels and watching these reels, 30 seconds, the video formats are going down. We are losing patience. And so we have to also build the application which is fast and which is also secure. Does that make sense? So far, so good? Perfect. So one of the issues that we also have is something called off-chain. What is off-chain? The concept is that it's very difficult to keep track of this data and then build some sort of data analytics on top of the blockchain. So one of the solution that we have is off-chain. People copy this data from the blockchain and put it on an off-chain, like a SQL or a storage accounts or whatsoever. And then run like Power BI on top of it or data analytics on top of it to build some sort of meaningful analytics out of it. The issue is, now if you're copying it to a storage, if you're taking it out of the chain, the benefit that we had on the chain was immutability. But you can change the data on a SQL. But you can change the data on a storage. So we're using that power that we had from the blockchain itself in the first place, right? So probably it's not a solution that fits for everyone. So what is the solution? The solution, one of the solutions probably, is using SQL database ledger. How many of you work on SQL? Wow. So the good thing about this setup is that the ledger functionality works on your existing SQL databases. So you just have to convert your database or your tables into a ledger-enabled table. What does it mean? I will come to that. But what are the benefits? That it basically gives you a historical change of this database, and to make sure that whatever changes that goes in, you have a historical table to make sure that you have all the records of the changes that have gone through this database. If this one does not make sense to you, don't worry about it. I'm going to go deep inside it. We'll have a demo, so I will make sure that you know what I'm trying to say by the end of this session. So another thing that we need to talk about is there are two kinds of table. Ledger tables, like appendable and append only. I think the name suggests itself. Appendable is basically where you can, updatable, where you can update the table itself. But append only means where you cannot make changes. You can only insert to a table, but you cannot run the update commands, where you cannot modify a data. So what we are going to do is we are going to look into it, how it works. But what happens over here is that in the SQL, we have this table. And for every table which is updatable or append on the ledger table, we also have a ledger view. So what happens is we create this block whenever there is a new data. We basically run it frequently, so probably between 30 seconds to 1 minute, automatically it happens by the SQL itself, that it creates these blocks over here. And these blocks basically is generated, and this data has to be now stored somewhere, right? We are generating a blockchain. Now blockchain has to be stored somewhere, right? So we put it in a trusted storage. What is this trusted storage? We'll come to that. So the idea is that every transaction that is going in, we are generating a hash out of it. And we know that if we change even one alphabet in something, one character, the hash completely changes, right? So hash basically identifies that the data that we have is the same data that we generated the hash for, right? So if we make any temperament to the database, then the hash will change automatically, right? So what we do is we keep on generating these hashes and put it in blocks. And we use these blocks, put it in a trusted storage. Does that make sense till now? Yes? Perfect. So next thing is the append only. Because it's append only, that means all the records are there in the main table itself. We don't need a history table because we are not modifying the data, right? All the data is there in one table itself. We need a history table because we are making changes to the original data. So we can identify the data which has changed, which has tampered or whatever, right? So that's why we use the append only. So talking about the storage. So there are a couple of options where we can store the blockchain. So we talk about in this slide, right? This trusted storage. So apparently there are like three options. One is you can host it in your own blockchain as well, which you are hosting it on premises, let's say. Another option is blob storage. So I'm not going to go deep inside it between the difference, but the overall idea is that in a blob storage, it's an immutable blob storage. That means it cannot be changed, right? And then there is another service from Microsoft themselves is ACL, Azure Confidential Ledger. The main thing is that this is more Microsoft-centric, and this is more open source. Now, this is built on top of open source technology, but it's hosted and managed by Microsoft for you. So you can either store it in your own blockchain, or you can either store it in the Azure storage itself in a block container. Does that make sense? I hope all of you worked on Azure already, right? So I don't have to explain this portal to you, right? Perfect. So what we are going to do is we will try to build a new SQL resource, but I can show you the security settings that we need to make sure that we are putting it as on a storage with a distributed ledger. Now this is the place where we have to make some changes. If you see over here, we have this option of ledger. So this is when you're creating your new database. But there is also an option to use your existing databases that you're running in your own premises or in your SQL Azure, and then modify that to be supported with a ledger. But once you switch on a ledger, you cannot turn it on. Oh, turn it off, sorry, my bad. Do you know why? Because of security. That means if a hacker, if someone has access to it, they cannot deliberately go ahead and then turn it off for you, right? So over here in the ledger, what we say is configure ledger. So we can say enable for all the tables, but over here, the digest storage that where we want to store the blockchain data itself, the hash that we are generating and saving it in blocks, right? Then we have two options. Either we can store it in a storage, we discuss about it in a block container, or we can use the Azure config ledger. For this demo, we'll just go ahead with a storage account. I already have a storage account, so I will not create a new one. This is standard settings where what kind of correlation you need, the maintenance window, nothing. So now I can go ahead and create it. But I'm not going to create it because this demo is going to work like a cookery show. Have you seen a cookery show? Everyone? Anyone? No one? So what happens in a cookery show, they put the pizza in the oven, and next second itself, they say, okay, the pizza is out of the oven, the pizza is ready. So you guys don't have to wait for the pizza to be baked. And that's what I've done. I've already created another database, which is quite basic, and I'm going to basically jump onto that and then show you the already created one. So I created this database, and all of you are familiar with these T-SQL queries. It's quite basic anyhow. What I've done is I created a database and then created a table called account. It has four properties: the customer ID, last name, first name, and the balance. Quite basic, right? Now, if you see over here, this is the property, this is the setting that you basically have to do. Send system.versioning is equal to on. This is for your existing tables, which is already running in your production. Like, don't put directly on production. Try it with your dev and QA first. But the idea is that the databases that you have already been using, right? You can switch it on for your existing production applications as well, and then the current enterprise application that you're working on. So I created this table, and then I inserted a couple of data in it. So let me put what's your name, sir? Sudarshan. Full name? Babu. So let's add an entry for a friend here, Sudarshan. And I will put a lot of amount for you. If you're going to work on blockchain, you will get money, trust me. So I was running it on the master. I have to select the right database. What's the issue? Apparently, I gave you too much money. I wish I can make you that rich in real life and then share something with you. But even my database couldn't handle that kind of money with you. So we all know how to create a table. We have created a table. We created one more record and inserted it. Quite basic? Yes? Perfect. Now I will go to the update query, which is also quite basic. And before I go to update, I want to go here and show you the current records that we have in the table. We can wait. We don't have other sessions to attend. We can wait for it, right? This is what we want to avoid when we are building our applications. Meanwhile, do you know how to query a database? You see right now, I have 3 records in my table, right? We have some data in it, but what I realize now that the data that I have for Sudarshan is probably way too much money, right? Should we reduce some money or give him some more money? What do you guys think? More? Reduce? More? Oh, nice. He's sharing some money with you, huh? I will put one more $. Not again. Now what I have done, I have changed this data, right? This data can be changed by us, the admins, the application, but it can also be changed by our friends called hackers who can penetrate into a network. I hope not, but let's say there is a scenario when they were able to do it. Now, how do we identify were they able to do it? How do we identify what are changes they have made? Right? We want to revert to the right database, right? But we don't know what are the changes. So we have something called PITR, point in time restore. But only if we know that at what time they entered our database and start changing. We might not know. And we also want to see what are the records they have changed, right? So we need to know what all happened in the past with the history table. And this is what we are going to see now. So as I said, with all the tables, there is also a hidden history table created. But there is also a view which is created. So you see over here, we have the history, we have this view. In the history table, we are storing all the transitions that we have done. In the actual table, we have the updated table with the right values that is supposed to be needed. But this view basically gives you an idea of what transitions that has happened. So what happens is, we don't say delete because we delete the previous record when we make an update and we add a new entry, so that we can easily identify what was inserted, what was deleted. Does that make sense? Yes? Now, let's say if you were hacked, you will be able to identify what all changes does the hacker made into your database, and you will be able to cherry pick it or basically revert back to the original state. But it's also good for the auditing purposes to make sure that your data is not tampered. How many of you have gone through an auditing process? No one? Oh, it's quite fun, trust me. So when an auditor comes, they want to make sure that you're top of everything and anything and everything probably. And your database, which is the most crucial thing, right? I work for a company and my job is basically to make sure that the production workloads that we have. So it's a SaaS company and I am responsible for running the SaaS environments. So data should be secure and the application should be up and running 24/7. They should be performant. All sort of that stuff is basically under my plate. So one of the things that we do is when an auditor comes, we have to showcase them that we are on top of the stuff that we have been using. Which means that if we are, so we cannot guarantee that we cannot be hacked. But the idea is if we are hacked, we have process in place to make sure we can minimize the impact of it. So first of all, we put a lot of security layers to make sure that getting into our database or getting into our network is quite difficult. But if anything is going on the internet, no one can say that it's 100% secure. There is nothing called 100% secure. You can make it more and more difficult to penetrate. But even in the worst case scenario, if you're able to penetrate, how you can make sure that you can get on top of the stuff and then revert it back to a situation where you have the production data workload running 24/7 or it's tampered proof. So that's the idea of audits. And with this, we'll be able to identify that and we'll be able to basically revert back if it's needed. Now, the next thing is that let's say if someone comes and then if a hacker comes and changes this blockchain and put it to another blockchain itself, creates an own blockchain and then put it there, how will I get to know? First of all, whether the hashes that we have on the on this table right now and which is stored in the blockchain, we need a way to verify it, right? Whether the hashes that we have for this SQL table versus the hashes that we have stored in the blockchain, they are same or not. Yes? So what we'll do is we'll create a hash which is already created and we'll do a verification process. So the next step is every single time I'm running it on the master. At least I'm consistent with it. So you see, I ran this command. This is basically a stored procedure which is created by Microsoft themselves. So the idea is that we create a hash of our database, and then we also query the hash of the blockchain that we have. We query the blockchain, take the hash from there, verify it. If the verification is successful, if there is no tampering in the data, this record over here, the result will be updated accordingly, says that whether verification succeeded or failed. If the hash is mismatching, that means someone came and tampered with the data, right? Now, you can see what is the last verified block, because we talk about blockchain, when we create blocks, it gets added. So the latest one is 5, and till there it has verified. Similarly, over here, if you see, there is a path. This is the path of our storage account, the blob storage, the immutable blob storage that we use, because we want to make sure that the hacker didn't came and put their own storage account link or own blockchain wing to make sure that they basically can tamper the data, now change the location of the blockchain, and then we are running this command saying, okay, it's matching the hashes, but you also have to make sure that it's matching with the right blockchain, right? So this is what we are doing over here. If we can go inside it, we can see the location of it, and there is also a property called that we can go inside and see whether it's been changed or not. So what is the current one? So you can get it's a JSON array basically. If someone has changed, you will get it in an array. We didn't change, so we only have like one record over here. Am I clear till now? So going back to the PPT, so these are my backup slides. So what are the scenarios where we can use it? The big scenario that we have is streamlining the audit process itself to make sure that if there is an audit, we can verify that there is no data temperament in the SQL database that we have been using. We also talk about having that trust that we build with blockchain, right? But we might not need that distributed ledger, right? Because it can be still centralized the way we have it. Right now, the ledger is centralized in our demo, right? Where we were storing it in what? I cannot hear you guys. In a blob, correct. So we still establish that trust, but we don't need that trust to be verified with a distributed ledger. And that's the difference between a blockchain and a ledger that we have been using. So the traditional blockchain, I would say. And the off-chain store that we've talked about, that we take the data, put it on off-chain, and then run all sorts of these queries, the data analytics tools on top of it to generate some value out of it, some analytics out of it, right? Like Power BI and stuff. So we copy the data from the main blockchain to the off-chain. So we don't need that in this scenario because we are already running it on an off-chain, but we are still securing and getting that trust of the database that we have. Am I clear to you now? Perfect. So what are the different difference that we have basically between the SQL ledger and the blockchain? So SQL, main thing is that you cannot do tokenization of assets. So it's a concept of blockchain that you create token. It's been used for transferring money. So a lot of your cryptocurrencies basically is built on these scenarios. How many of you use Ethereum or heard about Ethereum? So it's used something called ERC20 token. Similarly, there are a lot of other cryptocurrencies which is built on these platforms. So we cannot build cryptocurrencies with this setup, but the trust that we want to generate with the power of blockchain, that we can do with this setup itself. So it's a clear definition of what can be done with SQL ledger and where should we use it. So I'm going to share this PPT with you guys, so you guys will have access to the PPTs, and you can go through it. But so thank you guys. Thank you for having me.